Hello guys, in this video we're going to see how we can write flash loans using Solidity and especially how we can use it using Aave V3. Just before diving into the code, let's just try to understand what is a flash loan. So basically a flash loan will be like during a transaction, you will borrow a large position of assets that you're going to repay at the end of the transactions. So basically, it's allowed to leverage a position only during a transaction, allowing you to do like some arbitrage, rebalancing, whatever you want. But in the end, you will still have to repay. So you cannot just borrow the assets and leave it. You will have to repay the protocol. So yeah, during this kind of video, we're going to see how we can use it using Aave V3. There exist other providers as Balancer, Uniswaps, but for this one, we're going to focus on how it works with Aave. So a flash loan, as I said, is one transaction where you're going to borrow a high position, and then you're going to repay it at the end. So here is a kind of a workflow of how it's going on. So during this tutorial, we're going to create like a smart contract where we have like the first function that's going to request on Aave pool a flash loan. So by doing so, we're going to provide like the list of assets we would like to borrow and also the amount. On Aave pool, what's going to say is first going to transfer like the different assets directly into like the smart contract and call the execute operation function that we will need to implement. Inside this function, we can do whatever we want. It can be arbitrage, rebalancing, whatever. But then at the end, we will have to approve the tokens to the Aave pool in order to repay the loan. And we will have also to pay some fees for the protocol. And on Aave side, so in the end, they're going to verify like the pool state, meaning that the state before the transaction and after this one will still remain like consistency. Basically, just verify that the amount that they are providing to you is getting back to them at the end plus the fee. So yeah, let's move on to the code implementation. So basically, Aave will have like two kind of interface that you can use. So the flash loan receiver and the flash loan simple receiver. The main difference between those two is on the simple one, you have like only one asset that you can borrow, rather than on the flash loan receiver, you can pass like a list of different assets. And so for the rest of the video, we're going to focus on this one, but the same logic would be applied the same for the simple one. All right. So here, basically, this will be like the smart contract implementation that we will have to do. So just what I want to notice here is the initiator that will be like the address that's going to request Aave. It might be confusing, but this is not the message sender that's going to do the first transaction. To be clear, let's say we have like another user here that's going to request our smart contract. So the initiator will not be the user, but rather the smart contract. And so this is something that we have to keep in mind. Of course, the user can directly call the flash loan, but for just, I would say like implementation, it is more simple to have a smart contract. All right, and then we have also the params here that could take any kind of arbitrary data that you want to provide to the contract. It might be interesting in case of arbitrage where you want to send some value and you want to use it during the flash loan. And on Aave, we have like some implementation contract that we can use that's going to help us, especially for the addresses to fetch directly the Aave pool address. So we just have to implement this one. Of course, the simple one exists also here. So here in that case, we will have like we create like an example contract that's going to inherit from two interface. So the enable and the flash loan receiver base. So this is the one that we have see previously. Why I'm putting like enable here is just to keep in mind that we need to put like access control over the different functions that we're going to provide. This is extremely important in case that you are deploying your smart contract on chain, as anyone can just have access to those functions if you don't put like access control, meaning that they can maybe execute some flash loans that you do not want because you have maybe like a custom logic that you have inside. So this is like a good practice, I will say. All right, and so when we inherit from the flash loan receiver base, we will have to implement the execute operation. So here is the different parameters that we have seen previously. Just before doing the code, we are going to do some requirements of the different kind of access control, I would say, on this function. We want to make sure that the one that is calling this function is the Aave pool, and the one that initiate this flash loan is this smart contract. Then we will have like the possibility to decode, I would say, some parameters that we have passed. So this is just for demo, but you can use it to maybe extract more information. And then you can implement like your own logic, either here or maybe here in the code. Basically, you can do like arbitrage, rebalancing, whatever you want with this. And finally, we have like also at the end to, I would say, repay what we have borrowed. So basically here we will have to iterate over our assets and to repay it with an additional fees that we have to pay to the protocol. And so for that, we just approve like the different on each assets the amount for the Aave pool. And then in the end, we do not forget to return true to be able to say to Aave that everything went well. So that part is like the function that's going to be called by Aave pool. And now we want inside our smart contract to call like the flash loan function. So for that, I've created like a basic function, so request flash loan, where inside we are going to call like the flash loan function from Aave. Again, there exists two implementation, one that will be for the simple version and the one that will say the traditional one. So here we will have to put like the receiver address. So in our case, it will be like the smart contract that implement the execute operation. Then we have like the list of the different assets we want, and also like the interest rate mode. So this is like a particularity with Aave. Aave is a lending protocol, and so basically they provide a mode where you can, I mean, in traditional like flash loan, basically the transaction will be revert if you don't repay what you have borrowed. So this is like the mode number 0, and this is like what you will see from Balancer and Uniswap. But on Aave, as it is a lending protocol, you can define that instead of repairing directly my debt, I can open a debt position directly on Aave protocol. And this is like the mode number 2 that could be interesting in some cases. And so, yeah, and after that, we will have like to define like on behalf of, that would be the address that we'll receive in case we are in mode number 2, the debt position. We found out also like the params. So this is like the parameters that can be defined and you can use inside your execute operation function that we have seen previously. And then the referral code. So the referral code in that case, it's not working. So we just have to put 0 for this one. So for the implementation, again, I've put like access control for this. I strongly recommend you to do the same for you, or to keep in mind inside the protocol on what kind of access I want to put for that. Then we will initialize, I will select the different assets and amount that we want. Then we will define like the interest rate mode. So in our case, we're going to put like 0. We just want the transaction to be reverted in case we don't repay the loan. And then just for the demo again, I have put it like an extra parameters that you can use, that we can use after that. Again, this is customizable based on what you want and what you want to do inside your flash loan. And then in the end, we can call from the pool like the flash loan function. We provide like the different information. So the address, that would be the smart contract, the different information that we have seen just before, and the parameters that we will use inside a flash loan. Another point that could be interesting to add is in case you want to make sure that I don't know, you have done like some arbitrage and you want to be sure that you have make some profits. You can do also like some requirements here by verifying that your balance is above what you have done before. This is like interesting in case you, because currently the transaction will be reverted in case you don't repay the debt, right? But nothing blocks you to do the same. Like if you don't have a profit, you can just revert the transaction and say, this is not interesting to me for this one. But again, you will have to pay some, still pay the fees for a transaction, but it might be interesting in case, as if you're using Flash loan, you're mostly doing like some leveraging position. And if in the end it's not worth it, you just want to revert the transaction. So it can be done here or maybe in another function that we call like the request Flash loan. So this is like the implementation part, but you may want to test it and verify that everything works as expected. And so for that, I've just created like a simple script allowing you to test, I would say, directly on the mainnet. So here I'm using Purge for that. And so I've defined like the different addresses that we are going to use. So USDC address and the Aave pool provider address. Then inside the run function, I'm defining like my private key. I'm defining also like my contract and then I request a flash loan. During development, if you are want to make sure that everything works as expected, what I strongly recommend you is to execute your for script by putting like a RPC. So in this case, I'm using mainnet for that, but you can use it also on the testnet. And then you can define like this flag, so the V flag, I would say, that's going to help you for debugging. You're going to see like all the different stack trace of what is going to call inside when you're calling like this function. And it can truly help you to understand what you miss, I would say, during the development and be sure that it is doing as expected. Again, this script can be used also on mainnet, and for that you can just do the broadcast. I mean, not especially on mainnet, but you can send the transaction, and for that you can define the broadcast flag that's going to send the transaction directly on chain. Again, what could be interesting is to put like some requirements here to make sure that your transaction is doing as expected. Maybe you want to make sure that you're earning some tokens and you are not losing some of them. So yeah, I think that we have kind of seen, I would say, how you can implement a flash loan and have like an overview of that. If you are more interested in, I would say, article, I've write one of them on Medium. You will find the link below where you can see like the different code and you can just use it for your own implementation. This video is maybe more easy to see as we saw like directly beside the code. But if you want to take time, feel free to take a look at this. Yeah, and I don't know if you are interested in maybe more Solidity development, feel free to subscribe to this channel. I'm going to create like some tutorials, and if you have some ideas for that, feel free to leave a comment. I'm a smart contract engineer, and so if you are looking for a developer, feel free to reach out. Yeah, and that's it, I will say. Thank you very much, and good luck for your Flash loan development.